Hello students, here we will study the topic ultrasonics. Ultrasonics is a branch of physics which deals with methods of production, study of properties and applications of high frequency sound waves. Now what are ultrasonic waves? Ultrasonic waves are sound waves with a frequency greater than 20 kHz. They are also called as supersonics. Now we are going to see production of ultrasonic waves. Now a device which produces ultrasonic waves is called as an ultrasonic transducer. Now we are going to see two methods of production of ultrasonic waves. The first method is magnetostriction method. Now this method operates on the principle of magnetostriction. So what is the principle of magnetostriction? When a ferromagnetic material is placed in a changing magnetic field, it experiences change in its dimensions. So now here the figure shows a ferromagnetic rod, and this ferromagnetic rod is placed along the axis of this coil. The two ends of the coil are connected to an alternating signal. It is an oscillator. This oscillator produces an alternating signal through this coil. And this current through this coil produces a changing magnetic field around this ferromagnetic material. When the current rises through the coil, the magnetic field around the rod increases. And when the current decreases through the coil, the magnetic field also decreases. And the increase in current produces an expansion in the length of the rod, and the decrease in current produces a contraction in the length of the rod. Every time the length of the rod increases, it produces a compression in this area, and when the rod contracts, it produces a rarefaction. And if the frequency of this oscillator is controlled so as to be greater than 20 kHz, the sound wave produced over here will also have a frequency greater than 20 kHz, and we can call this as a ultrasonic wave. The second method is the piezoelectric. Here we use a quartz crystal, and the principle is that when mechanical pressure is applied along one pair of faces of the quartz crystal experiences electrical charges on the opposite pair of faces. And the converse is also true. If electrical charges are applied on one pair of faces, then the quartz crystal experiences a compression and tension along the other pair of faces. So mechanical pressure is experienced by this pair of faces when electrical charges are applied on this pair of faces. Now this is a quartz crystal placed between two parallel plates, and these two parallel plates are connected to an oscillating circuit. This oscillating circuit produces alternating signal along this pair of faces. When there is one polarity of charge along this pair of faces, it produces a compression, and the other polarity of the charges produces a rarefaction, as this pair of phase alternately experiences a contraction and expansion, or a tension and a compression. So an alternating chain of compressions and rarefaction is produced over here, which is a sound wave. Now if the frequency of the oscillating circuit is so controlled that the frequency of the sound wave is greater than 20 kHz, then we can call this wave as a ultrasonic